Welcome students, this is your Unit 2 test review. I want you guys to do this on your own paper and bring this to class on Tuesday. Okay? I want you to draw the pictures, do all the things that are done on here, but I just want you to do it on your own paper and bring it in on Tuesday. Alright, so we're going to have a couple of literal equations on there. Literal equations just meant that you were going to solve for any letter that you were given. In this problem, the first thing I would do is just reverse these and put the 1/2 over here, BH like that, and put the A over there. We're solving for the B, so I go ahead and box all of this stuff. I think it's best to go ahead and get rid of this fraction. This fraction is dividing, so we multiply to get rid of those. Those cancel out, and so we just get BH. A times 2 is 2A like that. We're solving for the B, so we want to get rid of the H, so we're going to divide both sides by the H. B equals 2A over H, and that's all you can do to that type of problem. Right. This was a question off of our previous test, and we worked it on the board when we did our test review, but I want to talk to you guys about it again. If we have a perimeter of 35, that means that everything added up is going to equal 35. So we're going to take all the parts, 2x plus 3x plus 1, and then this is a distributive property, so we're going to bring it down also. Alright, and we're going to solve for x, because we're asking for what is the value of x. So the first thing I see is some double rainbow here, some distributive property. So that's 2x plus 6, and then bring down everything else. Then I'm going to combine my like terms. I see a 2x, a 3x, and another 2x. So that's 2, 5, 7x. And then I see a plus 1 and a plus 6, so that is 7. Bring down the equals 35. Draw a line down, box. Plus 7 gets a minus 7. 7x equals 28. When it's beside it, we divide it, so I divide both sides by 7. And x equaled 4. Okay. So the hard part on that one is just getting it set up. Perimeters add everything up, set it equal to the number that they gave you for perimeter. Here we have a continuous function. We know it's continuous because it's a connected line. We're asked to do domain. Remember, this was $, the robot. That's left to right. So let's use red for that. So this graph goes to here, all the way over to right there. So it covers the number down here and that number right there. X is domain. So this down here, this is 0. Okay? If you count backwards, 9, 8, 7, 6, 5, 4, 2, 3, 2, 1, 0. So 0 all the way up to 8. Put our less thans to start. Then we look, it does touch in both of those places, and so we have to put the less than part. Okay? Be careful, you guys keep wanting to start with this number, and that's not where the graph starts. Domain is an x, so that only can be one of these numbers down here. Right? Let's take a look at the range. In the range, the bottom is down here, and the top is up here. Range is y. The bottom is right here, that's 0. And the top is up here, that is 150. And so then we look, it does touch the bottom down there, so we put the line on it. It does touch the top up there, so we put our line under that. That was robot, which is bottom to top. Okay? Alright, this was just solved. Again, this was a question off of our first test that we took this year. We're going to draw our line down. The first thing I see is this distributive property that needs to happen over here. So that's 6x minus 5 equals 2 times x is 2x. 2 times 3 is 6. Then I want my x's on the left, so I'm going to move this guy on the right. So minus 2x to both sides. 6x minus 2x is 4x. Minus 5, bring down your 6. I'm still solving for this, so I want a plus 5 to both sides. I get 4x equals 11. And then the last step, when it's beside it, we divide it. So I divide both sides by 4. I grab a calculator. 11 divided by 4 is 2.75. I don't see that answer there. I know it's not those two, so it's one of these fractions. So then I hit math 1, enter, to figure out what fraction it is. So math 1, enter, and it takes it back to 11/4, so this was 11/4. Okay. Alright, so similar thing to the solving we did just a minute ago, except we're solving an inequality. Remember, the only difference in solving inequalities and equations is if you multiply or divide by a negative, you have to flip the sign. Okay, so here, no distributive property, no like terms. I'm going to slide a 1 in front of there, so that's negative 1x. So the first thing I see is that I want to get all my x's on one side, and I want them on the left, so I'm going to plus 1x to both sides. Negative 3 plus 1 is negative 2x, plus 2 less than or equal to, bring down your 16. I'm solving for negative 2, so that plus 2 gets a minus 2. So this becomes negative 2x less than or equal to 16 minus 2 is 14. And the last step, divide by negative 2, divide by negative 2. That becomes negative 7, and the sign will flip. Remember, these faces help us tell whether it's a solid or, a open dot or a closed dot. So this symbol always gets a closed dot, so a closed dot at negative 7. This is pointing to the right, but if you hadn't flipped it, it'd be pointing the wrong way, so this is a picture of that graph. Alright, some different examples of functions. For pictures of functions, these are some pictures of functions. Remember, it had to pass the vertical line test, so each time I draw a red line down, it can only hit once. An example of something that's not a function would be something maybe that goes sideways like that. See how that hits 2 times, so that's not a function. It could be anything like this with a vertical portion to it, because that's going to hit multiple times down through there. In a table, to be a function, you just have to have different numbers on the left-hand side, on the x side. On the y side, you could have the same numbers or different numbers. It doesn't matter on the y side. So an example of something that's not a function: 1, 1, 2, 5, 5, 6. Whoops, 5. Let's do 5, 6, 6. So this is not a function because the 1 repeats like that. Okay. Some other examples, if we had a mapping: 1, 2, 3, 5, 7, 1, 2, like that. So on a mapping, you can only have one arrow leaving each time to be a function. For not a function, you'd have something like this: 1 goes with 5, 1 goes with 6, 2 goes with 7. So the fact that this has 2 arrows leaving is what makes it not a function. Okay, we could also do ordered pairs. Ordered pairs basically follow the same as the direction as the table. So if we had 1, 2, 4, 5, 7, 8, all we would do is look 1, 4, 7. That is a function because those are all different. An example of something that's not a function: 1, 2, 2, 3, 2, 5. Because this 2 repeats, that's not a function. Just simplify kind of the first thing we started with at the very beginning of the year. It's distributive property, combine like terms, and then you're done. So this has distributive property because I see the parentheses. 3 times x is 3x. 3 times a negative 6 is negative 18. Be careful, you guys draw this second arrow sometimes, but you don't do that second arrow, so make sure that you do that. Bring down everything else. 7x minus 8. Then we're looking for like terms. 7x plus 3x is 10x. And negative 8 and negative 18 is negative 26. And so 10x minus 26 is your answer. Okay. Be careful, a lot of you guys like to do stuff like that. You try to combine those. That is not right. Do not do that. Okay. This is the same problem we talked about the other day with Kiera. I want to show you guys how I drew the graph again. When I see that this is speed versus time, then I know this is speed versus her time. Okay. We go back through and reread the problem. When she applied the brakes, it took her 4.5 seconds. So this graph ends at 4.5. Here, it's going to be 0 in both directions. She had a top speed of 20, so this is 20 miles an hour. So in domain is our x. It goes from 0 to 4.5. So this is our domain. Up here, this is going to be our range from 0 to 20 there. Remember, I always talk about hidden numbers. Your hidden numbers in this one were the zeros here. Sometimes if they give you a formula, you have to use the table to help you find your hidden numbers. but in this case it's really best to draw a picture of that. Alright. The last type of problem we did on Friday in class was I gave you a function like y equals 6x minus 8 plus 3x, and I said if I give you a domain of 1, 4, and negative 9, could you find the range values that go with that? And so we talked about in class that it's best to go ahead and just make a table, and we learned that this is x and y, which is domain and range. Remember we did Dr. XY to help us with that. So these are domain values, so I'm going to put them over here, 1, 4, and negative 9. I won't need that last column. We say go to your calculator and type in y equals. So I go to my calculator, go to y equals, clear out anything that's there, 6x minus 8 plus 3x, and I hit, so in y equals I put it, and then I do second table, which is a graph, second graph, and then I look in here at 1, it goes with 1, at 4, it goes with 28, and then I gotta scroll way back up to the top, negative 9 goes with negative 89. So we're supposed to put them in order from least to greatest, so it'd be negative 89, comma, 1, comma, 28. Okay. Don't forget to bring this in on your own paper and have it ready for us to check on Tuesday.